So let's look at the functions or the eigenfunctions for the one-dimensional prism, which we know if the particle is forced to live between x equals 0 and x equals L, so 0 and L, then the functions are square root of 2 over L, sine of n pi x over L. So let's plot these functions. These are real functions, and see what their symmetry is, or rather their parity. And we'll see that they're alternatively even and then odd. So psi 1 of x goes like sine of pi x over L. So if we plot that, what does that look like? Well, it goes to 0 at x equals 0 and x equals L. And so it just looks like that. So with respect to the midpoint, L over 2, we see that the function just repeats itself, right? We just rotate it about the axis, a vertical line there at L over 2, and we get the same function. So it has even parity. So what about psi 2? Psi 2 of x, that's sine of 2 pi x over L. If we plot that, it's going to go to 0 in between. So it's 0 here. All these functions will be 0 at x equals 0 and x equals L. But this one goes to 0 also at L over 2. And so it looks something like sine of 2 pi x over L also goes to 0 at x equals L over 2. So notice that if we think of this vertical line going through the midpoint of the well, then when we rotate that side, we have to multiply by a minus sign to get the function. So the parity is odd for this one. And now we'll come back to having a function that is even. So psi 3 will have even parity. And if we plot it, what does it look like? Well, it will have two more zeros. It will have a 0 at L over 3 and 2L over 3. And so we would make the function come up, down. Then it reaches its lowest point at L over 2, and then it just repeats because it's an even function. So we're going to come up here and come down here like that. It's a little too high there. Basically, that's the function. And so we can see that that has even parity. And if we do psi 4, eventually it starts to get a little tricky. Psi 4 this has to be odd, so it's going to come, right, the odd parity functions go to 0 at the midpoint, so this one has to be 0. So what we're getting is we have a certain parity, and then we just have greater waviness. We have more nodes, more places where the function goes to 0. So this one is going to go to 0 just like this one does. Of course, it goes to 0 at the endpoints as well. But we also have to make it go to 0 somewhere else at one more point. So it's going to end up coming up here. So it has to come down here and come up here and do something like that. And then it's just, right, has odd parity. So if we flip this function, we have to multiply by a minus sign. So what does that look like here? Come up like this, and we come down like this, and we look like that. Did I do this right? This looks like, yeah, if I rotate it about there, then I multiply by minus sign, I'll get that function. So it kind of looks like it just repeats itself if I shift it over.